Alright, here's the problem. They give us a binary array, meaning that it only contains zeros or ones in the array, and we want to find the maximum length of a contiguous subarray that inside this subarray have equal numbers of 0 and 1. And then at the end here, they give us a constraint saying that the length will not exceed 50,000. We can see how we can use that to optimize our solution later. But first, let's dive into an example. So here's an example in which the answer is 4. So the answer here is 4. You can see it by either taking the last 4 or the second last 4 elements. Now, one possible way of doing this is to go through every single possible subarray. So, you check the answer to this, check this, check this, check this, check this. And then you see nothing. So now you check with the second element starting. You check here, 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 here. And then, so on and so forth. Now, that's not very efficient. So one way we can make this more efficient is we're going to introduce the concept of having a sum. In which case 0 maps to a -1 and 1 maps to a +1. So if we use this sum on here, we can see that in our sum array, in our running sum, we're going to see that here is -1, -2, -1 because we add 1 back, -2, -1, -2. Now notice that what this says is that when we're here, we're saying that we have an array with one extra 0. And here -2 says that this array has 2 extra zeros. And then here, this array tells us we have 1 extra zeros. So notice that in here, when we have equal values, -1 and -1, it says we have 1 extra 0 here and 1 extra 0 here. What this means is that if we were to take away this and then create a subarray here, this would have no extra zeros. In other words, this would have equal amounts because, 1 extra 0 here, 1 extra 0 here, take away that extra 0, then we have equal amounts. And indeed, you can see here, we have a perfect 1, 0, 1, 1, and we found a possible solution with a length of 2. Now, continuing on, we have -2, and we see that we also have the same thing happening with -2. So -2, we have here all the way to here. There we have a possible solution. Now -1, we see it again. Now with this -1, we are going to compare it not with this -1, but instead with the first -1 that we've ever seen, because we want our maximum subarray to be as big as possible. So this tells us if we have, let me get rid of this. This tells us that if we have a subarray here, that started from here, we have 1 extra 0, and then we have subarray here that have 1 extra 0. So we take what's in between, which will be equal. And this, in this case, now it's 4. So we've seen a better solution. And we can continue on like this and find that the last one we have from here all the way to here. And we also have 4. And then we just return the maximum, which we've seen so far is 4. Okay, so this will be our algorithm. And now we need to find out, how are we going to find out the first index when something happens? So whenever we see a -1, we're asking ourselves like, hey, have we seen a -1 before? So what we'll do is we will use a map. For now, let's use a hash map. And this hash map will give us, for a given sum, what's the first index where we saw it at. So here, when we're looping through our array of 0, 1, 2, 3, 4, 5. We're going to get to 2. Imagine that we got to 2. We see -1. And then we're asking ourselves, have we seen -1 before? And the answer is yes, here, which had its first index at 0. And then when we do our I minus 0, which is 2 minus 0, we're going to get an answer of 2. And this 2 is exactly the length from here to here. And that will be our solution. Okay, let's try coding this out first, and then we'll see where we can continue from there. So as we code it out, we know that we're going to need some sort of a map. Let's have our map. And now let's iterate through nums.length. Okay. And now we also need some sort of a sum, which will start off at 0. And I guess one case that we haven't mentioned is, what if we see something like 1, 0? Then in our sum, we are going to see, let's see, 1 will give us 1, 0 give us 0, and we'll see a 0 here. And then we'll want to look into our map of when's the first time we've ever seen 0. And the solution to that is going to be -1. So like before we even started our loop, we've seen -1. That way when we do, so this is I equals to 0 and 1. When we do 1 minus -1, we're going to get our correct answer of length of 2. So we want to put in our map that we've already seen the sum 0, and that occurs when the array hasn't even started yet at -1. So it's not 1 here because 1 we've already started our array, and here we can see that our sum is 1. Okay, so so now we have our sum, and we want to add 1 if nums at I equals to 1. And otherwise we want to add -1 if nums at I equal to 0. The equation that we're going to use for this is going to be nums at I times 2 minus 1. So you can see here that if nums at I is 0, then 0 times 2 is still 0 minus 1 gives us -1. And in the other case, we will have 1 times 2 is equal to 2 minus 1 equals 1. So that will give us the mapping that we want. So here, nums at I times 2 minus 1. So if our map contains this sum, then we want to figure out the length. So the length will become map.get sum minus, let's see, I, so where we are now, minus map.get sum. And we will have some sort of way to track the maximum that we've seen so far. And here we have max is equal to, well, we'll see if the length one is even bigger. All right, else we're going to put that into our map. So map.put, for this sum, we saw it at index I. That's when we first saw it. Cool. Okay, and at the end, we're going to return max. So that should give us a solution that is correct if it compiles. Right. Here we want to do contains key. And then we'll try submitting it. Okay, so it's accepted, but we actually could do a little bit faster with the fact that the length of the given binary array will not exceed 50,000. That means instead of a hash map, which has amortized constant time, we could use an array that also have the same, that where we can also map, the index of the array is the sum, and the value map at index is going to give us the index in nums when it first appeared. So we can do something like that. So let's explore this a little bit further. Okay. So first we need to know how big should our array be. Well, we know, first of all, that we'll never get more than 50,000 elements. So that's, for example, let's say our length of the array is equal to 3. This is the input array. So it could be 0, 0, 0, or maybe something like 1, 1, 1. And we need an array that can map all the possible weights. So if this is 0, maybe we have a sum of -1, -2, -3, which would happen in this case, right? -1, -2, -3, or it could go all the way up to 1, 2, and 3. And this, the value of our map. So here's our map. It's going to be the index when it first appeared. So for the example of 0, 0, 0, it will be 0, 1, 2. We first saw an index of 0 at -1, continue on like that. So here we have an answer for what our length should be. So the length of our map should be the length of our array, so L, times 2, so that we get both sides, plus 1 for our 0. So that's going to be the length of our integer array. Now the second problem we run into is that we can't actually go map at -3. That is not a valid statement. We can't index into negative numbers. So we need a way to somehow transform -3, -2, 1, 0 into something where we can go 0, 1, 2, 3, 4, 5, 6. Now, I propose that we actually switch the order and we do something like this. 0, -1, -2, -3. Actually. No, I think this will be correct. So what we want is, instead of 0 here, our 0 is actually going to be L. And then when we see a positive one, we'll increment this way. And then when we see a negative, we'll go this way. So instead of starting at 0, our sum is going to start at 3. All right, if we code it out, I think it'll be a little bit more clear. So first we have our map. And now this map is equal to num_saw length times 2 plus 1 instead of our hash map. Okay, so we also need to have our int sum, and our int sum is going to be num_saw length instead, because we want to start out at 3, and if we see a 1, go this way. If we want to go the other way. And here we had a map put 0, -1. So we can do the same thing. We can have map at, so I guess here we'll have a 0. So what is our 0? Our 0 is when it's equal. So int sum is equal to equal. And this will still be -1, which is fine. And int max equals 0. Okay. So here, this will continue to work as we expected. Now we have this problem where we have to know if we've written to this key before. And the way that we can do this is to set it to, we need to initialize our map to an integer that we know won't be used ever. Yeah. So what that will look like is we are counting the first index, and our first index will only be -1. So we can initialize it to 2. So our empty is going to be equal to -2. And for int I equals 0, I less than num_stod length, I plus, empty map at I is going to be equal to empty. Now what that allows us to do is here, instead of contains key, we can go if map sum does not equal the empty, so we have filled something on top, then we do what we did before. So instead of get, it's now an index access. Otherwise, map at our sum is going to be equal to I. Okay. So I think that's it. That should also give us a correct solution. Okay, let's try submitting. Oh, looks like we messed up somewhere. We outputted a 7 when the expected was 0. Let's see where we could have messed up. Map at sum does not equal to empty. Then the length is going to be equal to I minus the first index when it appeared. Otherwise, max. Okay, that looks good. So maybe something up here. Map at I is equal to empty. Oh, nums.length. I see. So here it's not nums.length, but rather it's map.length. We want to make sure all of them are initialized to the empty. Okay. So we'll try submitting again. And now it's accepted. All right. So this solution, you can see, beats 100%, whereas before, I think with the hash map, it would have been around this bar. So, all right, that's the end of today, and I'll see you on the next one.